An anode is an electrode through which positive electric charge flows into a polarized electrical device. The flow of charge is an electric current. A common mnemonic is acid for anode current into device. The key notion is a positive current flows into the device. Positive charges are entering the device through the anode. There is a complication because a current is often moving electrons, and the charge on an electron is negative. Positive charge flowing into the anode is the same as electrons flowing out of the anode. Consequently, the direction of electric current is opposite to the direction of electron flow. Electrons flow out of the anode to the outside circuit. A widespread misconception is that anode polarity is always positive. This is often incorrectly inferred from the correct fact that in all electrochemical devices, negatively charged anions move towards the anode. Actually, by the above universal definition of electric current direction, anode polarity depends on the device type and, sometimes, even on its operating mode. Consequently, as can be seen from the following examples, the anode is positive in a device that consumes power, and the anode is negative in a device that provides power. In a discharging battery or galvanic cell, the anode is the negative terminal because it is where the current flows into the device. This inward current is carried externally by electrons moving outwards, negative charge moving one way constituting positive current flowing the other way. In a recharging battery, or an electrolytic cell, the anode is the positive terminal, which receives current from an external generator. The current through a recharging battery is opposite to the direction of current during discharge. In other words, the electrode which was the cathode during battery discharge becomes the anode while the battery is recharging. In a diode, the anode is the positive terminal at the tail of the arrow symbol, where current flows into the device. Note electrode naming for diodes is always based on the direction of the forward current, even for types such as Zener diodes or solar cells where the current of interest is the reverse current. In a cathode ray tube, the anode is the positive terminal where electrons flow out of the device, that is, where positive electric current flows in. An electrode through which current flows the other way is termed a cathode. Etymology: the word was coined in 1834 from the Greek a 1/4 I 1/2 I, ascent, by William Whewell, who had been consulted by Michael Faraday over some new names needed to complete a paper on the recently discovered process of electrolysis. In that paper Faraday explained that when an electrolytic cell is oriented so that electric current traverses the decomposing body in a direction from east to west, or, which will strengthen this help to the memory, that in which the sun appears to move, the anode is where the current enters the electrolyte, on the east side, ano upwards, ados away are. The way which the sun rises. The use of east to mean the in direction may appear contrived. Previously, as related in the first reference cited above, Faraday had used the more straightforward term asode. His motivation for changing it to something meaning the east electrode was to make it immune to a possible later change in the direction convention for current, whose exact nature was not known at the time. The reference to use to this effect was the Earth's magnetic field direction, which at the time was believed to be invariant. He fundamentally defined his arbitrary orientation for the cell as being that in which the internal current would run parallel to and in the same direction as a hypothetical magnetizing current loop around the local line of latitude which would induce a magnetic dipole field oriented like the Earth's. This made the internal current east to west as previously mentioned, but in the event of a later convention change it would have become west to east, so that the east electrode would not have been the way in anymore. Therefore asode would have become inappropriate, whereas anode meaning east electrode would have remained correct with respect to the unchanged direction of the actual phenomenon underlying the current, then unknown but, he thought, unambiguously defined by the magnetic reference. In retrospect the name change was unfortunate, not only because the Greek roots alone do not reveal the anode's function anymore, but more importantly because, as we now know, the Earth's magnetic field direction on which the anode term is based is subject to reversals whereas the current direction convention on which the asode term was based has no reason to change in the future. Since the later discovery of the electron, an easier to remember, and more durably correct technically although historically false, etymology has been suggested, Anode, from the Greek anidos, way up, the way out of the cell for electrons. Flow of electrons. The flow of electrons is always from anode to cathode outside of the cell or device, regardless of the cell or device type and operating mode, with the exception of diodes, where electrode naming always assumes current in the forward direction, that is, electrons flow in the opposite direction, even when the diode reverse conducts either by accident or by design. Electrolytic anode. In electrochemistry, the anode is where oxidation occurs and is the positive polarity contact in an electrolytic cell. At the anode, anions are forced by the electrical potential to react chemically and give off electrons which then flow up and into the driving circuit. Mnemonics, LEO red cat, or inox red cat, or oil RIG, or Roman Catholic and Orthodox, or LEO the lion says GER. This process is widely used in metals refining. For example, in copper refining, copper anodes, an intermediate product from the furnaces, are electrolyzed in an appropriate solution to yield high-purity cathodes. Copper cathodes produced using this method are also described as electrolytic copper. Battery or galvanic cell anode. In a battery or galvanic cell, the anode is the negative electrode from which electrons flow out towards the external part of the circuit. Internally the positively charged cations are flowing away from the anode. But, external to the cell and the circuit, electrons are being pushed out through the negative contact and thus through the circuit by the voltage potential as would be expected. Note: in a galvanic cell, contrary to what occurs in an electrolytic cell, no anions flow to the anode, the internal current being entirely accounted for by the cations flowing away from it. In the United States, many battery manufacturers regard the positive electrode as the anode, particularly in their technical literature. Though technically incorrect, it does resolve the problem of which electrode is the anode in a secondary cell. Using the traditional definition, the anode switches ends between charge and discharge cycles. Vacuum tube anode. In electronic vacuum devices such as a cathode ray tube, the anode is the positively charged electron collector. In a tube, the anode is a charged positive plate that collects the electrons emitted by the cathode through electric attraction. It also accelerates the flow of these electrons. Diode anode. In a semiconductor diode, the anode is the p-doped layer which initially supplies holes to the junction. In the junction region, the holes supplied by the anode combine with electrons supplied from the n-doped region, creating a depleted zone. As the p-doped layer supplies holes to the depleted region, negative dopant ions are left behind in the p-doped layer. This creates a base negative charge on the anode. When a positive voltage is applied to anode of the diode from the circuit, more holes are able to be transferred to the depleted region, and this causes the diode to become conductive, allowing current to flow through the circuit. The terms anode and cathode should not be applied to a Zener diode, since it allows flow in either direction, depending on the polarity of the applied potential. Sacrificial anode. In cathodic protection, a metal anode that is more reactive to the corrosive environment of the system to be protected is electrically linked to the protected system, and partially corrodes or dissolves, which protects the metal of the system it is connected to. As an example, an iron or steel ship's hull may be protected by a zinc sacrificial anode, which will dissolve into the seawater and prevent the hull from being corroded. Sacrificial anodes are particularly needed for systems where a static charge is generated by the action of flowing liquids, such as pipelines and watercraft. Sacrificial anodes are also generally used in tank-type water heaters. In 1824, to reduce the impact of this destructive electrolytic action on ships' hulls, their fastenings and underwater equipment, the scientist-engineer Sir Humphrey Davy, developed the first and still most widely used marine electrolysis protection system. Davy installed sacrificial anodes made from a more electrically reactive metal attached to the vessel hull and electrically connected to form a cathodic protection circuit. A less obvious example of this type of protection is the process of galvanizing iron. This process coats iron structures with a coating of zinc metal. As long as the zinc remains intact, the iron is protected from the effects of corrosion. Inevitably, the zinc coating becomes breached either by cracking or physical damage. Once this occurs, corrosive elements act as an electrolyte and the zinc-iron combination as electrodes. The resultant current ensures that the zinc coating is sacrificed but that the base iron does not corrode. Such a coating can protect an iron structure for a few decades, but once the protecting coating is consumed, the iron rapidly corrodes. If, conversely, tin is used to coat steel, when a breach of the coating occurs it actually accelerates oxidation of the iron. Related antonym, the opposite of an anode is a cathode. When the current through the device is reversed, the electrodes switch functions, so anode becomes cathode, while cathode becomes anode, as long as the reversed current is applied, with the exception of diodes where electrode naming is always based on the forward current direction. See also. References. External links, the cathode ray tube site, how to define anode and cathode, Valence Technologies Incorporated Battery Education page, Cathodic Protection Technical Library.